Okay, we have our 3.2 notes, which is linear functions. How can you determine whether a function is linear or nonlinear? So the first thing that you need to do is go ahead and stop this video, write the outline of the notes. We're going to go over them. There's only one example, I believe. It's example A, B, C, and D, deciding whether we have a linear or nonlinear function. So I'm going to go ahead and get started. A linear equation in two variables. That means we have x and y. A linear equation is y equals mx plus b. This is also known as slope-intercept form. We've identified the slope, which is your m. Your y-intercept is your b value. And here are some examples of slope-intercept form, okay, a linear function. Now, we just want to make sure we have an equation that is in y equals mx plus b form. If it's not, like this example down here, we just want to make sure we can actually put it in y equals mx plus b form. So you isolate the y value and you subtract x, and then we'll have it in y equals mx plus b form, slope-intercept form. Here we have a function, y equals 2. This is a horizontal line. And when you see an equation that says x equals -1, that's a vertical line. That's what it would look like. Okay, so just keep that in mind. These are still linear functions. What is a nonlinear function? Does not have a constant rate of change. So what does that look like? Graphically, it's not a line. So if you have anything that's curved or, you know, a circle or swirly on a graph, then we don't have a function. So that's what we're going to look at in example 1. Does the graph represent a linear or nonlinear function, and explain. If you don't have a graph, then we have some tables, table of values. So we want to be able to look at it and decide if this is going to create a function or not a function, okay? So remember, we said linear function. If you look at the word linear, a word comes into mind, line. Linear function is a line. So here we have more of a curved graph. This is an example of a non-linear function. The graph is not a line. And there's your explanation. Let's take a look at B. We do have a line. So we do have a linear function. And the graph is a line. Okay. Two quick examples, and let's move right along into example C. Okay, so what you want to do is, remember we said by definition, well, nonlinear, we said it does not have a constant rate of change. So what that means, a linear function does have a constant rate of change. And what you're doing is you're looking at your values, and you want to ask yourself, if you have the same pattern with your y values, if there's a constant rate of change, then we have a linear function. If it's not, then we do not have a linear function. Okay, so you want to check, and you want to check all of the values. So you don't want to just check between 3 and 6 and 6 and 9. You want to check all the values. So you're asking yourself, what do I need to do to get from 3 to 6, 6 to 9, 9 to 12? What number? And it looks like the number that I'm adding is 3. So let's check our work. 3 plus 3 is 6. 6 plus 3 is 9. Good. 9 plus 3, we end up with 12. Okay, so now let's check these values down here. 36 to 30. So we're starting with a large number, and it's getting smaller. And the number that we're subtracting each time, well, for the first set is 6. 30 to make 24, we have to subtract 6. 24 to 18, very nice, 6, -6. So because we have a constant number that we're subtracting, this is called a linear function. This is a linear function because the rate of change is constant. Okay, last one. We're going to do the exact same thing. I'm going to use a different color pen. From 1 to 3, we're adding 2. 3 to 5, we're adding 2. 5 to 7, we're adding 2. 2 to 9, we're adding 7. 9 to 20, we're adding 11. And 20 to 35, it looks like 15. Okay. So as I'm looking at this, I notice that we're adding 7 and then 11 and then 15. So the rate of change is not constant. There is no constant rate of change. So this would be an example of not linear. And when the rate of change is not constant, if we were to graph this, it would be a curve, okay? Or points will be all over the place. Whereas if we were to graph C, this table, we would have a line, a linear function.